All right, so today we're going to talk about solving systems of equations, but you're going to learn something called the equal values method. The lesson that you did on Monday was about graphing. You graphed two equations and you looked where those two lines met, and wherever they meet, that coordinate pair is what we call the solution to that system. For those of you who are wanting to own your own business, to me, owning your own business is a perfect example of a system of equations because you have income, the money people pay you for whatever service, but you also have expenses, paying the bills, right? Providing your service, renting your office space, whatever the case may be. And once your expenses and your income meet up, that point of intersection, that solution, is where you start making money. And as long as your income, the money people keep paying you, is larger than your expenses, that's when you start earning profit, meaning making money. So those of you who want to go into business for yourself, that's where you might see a system of equations. It's called the break-even point. Okay, the break-even point. So again, on Monday, you learned how to do it by graphing, solving in slope, or graphing in slope-intercept form. Today, what we're going to do is take that same idea of when equations are both in y equals, and we're going to learn this thing called the equal values method. All right, so a couple of reminders. Again, that solution is where those two lines meet, like we just talked about, and then we write that solution as a coordinate pair. If you have two variables in your equations other than x and y, you write your coordinate pair in alphabetical order. Now, to find that solution, you're going to set the two equations equal to each other. So on Monday, you did graphing, and that's because those equations were written in the form of y equals mx plus b. And we talked earlier this school year that y equals mx plus b, that slope-intercept form is how you graph equations. Today, we're going to talk about how can I solve it without graphing when my two equations start with the same variable. So here's the steps. You're going to set those two equations equal to each other. You're going to solve for whatever letter is there using inverse operations. All the variables on one side, all the plain numbers on the other. And then you're going to take the number that you get and you're going to plug it back into one of the two equations to get the other number. And then we're going to write our solution as a coordinate pair. So I'll let you get caught up with this slide. If you're in person, give me a thumbs up when you're ready for me to move on. If you are at home, click the raise hand button so I know that you are ready. You need some paper? Okay. Do you need a pencil? Okay. Again, if you're here in person, give me a thumbs up when you're ready for me to move on. At home, friends, click the raise hand button when you are ready. I got you, Marcus. So again, on Monday, all those equations were y equals mx plus b. You graphed the y-intercept, which was the b, and then you'd move up or down, and then to the right and graph that line, and then you're looking for where those two lines intersected. So what we're doing today is taking it, instead of graphing it, we're going to solve it algebraically. Ricardo, good morning. While you're finding some paper and something to write with, just as a reminder, Ricardo, I need you to get that quiz in the lesson 4 folder taken care of, please. It's just 5 questions. And shoot me a message when you are ready. Or when it's graded. Not graded, when it's finished, excuse me. Again, click the little raise hand button at home when you are ready for me to move on to the next slide. We'll get through our example, and then you should have quite a bit of work time today to get today's, thank you, to get today's assignment finished. Does anybody need a little more time for writing down what's on the slide? All right, so again, we're going to set the equations equal to each other, solve for the first variable, plug that number in and get the other answer, and write it as a coordinate pair. Here we go. So here's our example. We're going to solve the equation, this system, W equals 8G plus 50, and W equals negative 5G plus 180. You don't have to write this adapted part down, but that's just where we found it in the CPM curriculum. So as you're writing that down, one thing you may notice is they both start with W. And this is exactly where we're going to use the equal values method, where both equations start with the same variable. So as step number 1 said, we're going to set those two equations equal to each other, because as we look right here, they both start with the W. Because they both start with that exact same letter, we can take negative 5G plus 180 and put it in place of W. We're setting them equal to each other. So here on the left-hand side, I've got 8G plus 50 equals negative 5G plus 180. All I did was take one of those W's out and replace it with that 8G plus 50. From here, we're going to do what we've been doing almost the whole year, and that's solve for that variable g, which means we want to get all the g's on one side and the plain numbers on the other. One thing to note, this green words, that's just the first step. So I would not necessarily take the time to copy that down since you already wrote those steps down from the previous slide. Now, in your head, hopefully you're thinking, what can I do to get all of the g's on one side together? And I notice that I've got this negative 5g. So I want to get rid of it or move it. So I'm simply going to add 5g to both sides of my equation. Now, remember, in doing so, that turns this into a zero pair, right? And that's why we wanted to add it. We have to get that to be removed. And whatever we do to the right side, we do to the left side. So that leaves us on the left, 13g plus 50. And on the right side, we've got this 180. And as you're looking at it, you should notice that you've got all the g's are gone from this right-hand side. So now I need to get rid of this plus 50. And what's the opposite of adding 50? You got it. Clear that 50 out. And we need to do that on both sides of the equation. And again, the reason why we do that subtracting 50, just like we did up above, is that we need this to turn into that zero pair. And to keep it balanced, we have to do that same thing to both sides of the equation. So on the left, we have 13g, and on the right, we have 130. Then from here, we know we need to get rid of this 13. And so what's our last step? Yep, you got it. Because we need to get that variable to be plain and by itself. And so you're going to divide by whatever number is next to that variable. That makes a giant 1, and it leaves us with g equals 10. So that's the first step. The only thing that's really different with that first step is putting those two equations together. Otherwise, everything we have already done, like the rest of what we did, is not new. We've done a lot of manipulation with equations this year. So at this point, solving for that variable should be something that we are used to. All right, so like we already know, we need to take this first number, this g equals 10, and we're going to plug it back into one of our two equations. It does not matter which one you put it in. You can put it in either equation and you would get the same answer. So I'm just going to take that g, that 10, and put it in place of g in this first equation. Whoops, there we go. All I did was take 10 and put it in place of g. And then we're just going to use our order of operations to find that value, to evaluate that expression. So we know 8 times 10 is 80. 80 plus 50 is 130. So that is our solution for W. And then we know that we're going to write our answer, our solution, as a coordinate pair in alphabetical order. So because we've got G and W, when we write our coordinate pair, we're going to write it as the pair of 10, 130. I'm going to move this up a little bit in case I moved it and people weren't quite ready for it. So again, you take those two equations, you set them equal to each other, do inverse operations to solve for that first variable, plug it back into either equation, get the other answer, and then you write your answer as a coordinate pair. Now, if you're wondering, could we have done a different coordinate pair? Short answer is yes, or I mean a different equation. I could have put 10 up here for this G, and let's just see what happens. If I do negative 10, or excuse me, negative 5 times 10, that gives me negative 50, right? Negative times positive. And then if I have negative 50 and I add 180, what does that give me? Yeah, 130, same answer, right? So notice we got 130 with both equations. So I just wanted to show you it does not matter which equation you pick, as long as you then do the evaluating part in the appropriate order. Okay? All right, again, this works for solving systems when both equations start with the same variable. Okay, equal values method. Again, it's the same thing as what you did on Monday, but instead of graphing, you're just doing it what we call symbolically or algebraically. Okay, does everybody have what you need off of this slide? All right. We've already talked about that. Again, the best time to use equal values method is when both equations start with the same variable. So that's what I've got for you. What you're going to do now is you're going to go into Schoology, everybody. Look for the Lesson 8 folder. This week's folders are, see what color are they? White, I think? No, not white. What are you? Yellow? We should be in yellow. So go ahead and go into Schoology, refresh your screen if you haven't done so lately, and then look for the yellow Lesson 8 folder, and your worksheet is in there. It's actually just 3 questions today. 2 of them are regular with equations, and then one of them is a little story problem one, but it's I walk you through the steps on it. And then when you're finished, I want you to check your grades and make sure that I am accurate with what you have completed. And then if there's time, I want you to take care of your missings. Okay. Ricardo and Johnny, now would be a perfect time for you to get those quizzes taken care of, please. And those are, again, are in the Lesson 4 folder.